Thank you very much. Yeah, today we will talk about Naemon and friends, since Naemon is a pretty small tool or engine usually behind the scenes or under the hood. We will also have a look at things that are built on top of Naemon to make it, to maybe give you a few ideas on what you could do or where to have a look. My name is Sven Nierlein. I'm working at Console, and I'm at least partly involved in a few of those projects you will see later on. And let's start with, no surprise, we start with Naemon. Quick recap on what Naemon is doing actually. Naemon is processing events somehow. We have, on the left-hand side, we have active checks and passive checks. They are coming into Naemon somehow. And Naemon then processes these events and produces alerts, metrics, event handlers, and or status data in general. And that's about it. That's Naemon. That's why this talk is Naemon and friends, because Naemon is doing really a little or a small job, an important job, of course, but it's not much more than that. It really processes events into other queues. So we try to focus on two things with Naemon. That's, like I said, we are following the Unix philosophy and do one thing and do that one right. And this also means we can do that as fast or as good as possible, of course. And in our case, we are running check plugins, and on the other hand, we are providing data and metrics to further tools. And that's the second thing. We try to provide APIs so other people can do stuff on top of Naemon. That's why you probably don't hear the word Naemon that often, because it's usually working under the hood and there are things on top, like I will show you later. So, but the main task for us is to provide APIs which are useful, helpful, fast, and reliable, so others can create awesome stuff on it. And this also gives you the freedom of choice to maybe replace different things that are working on top of Naemon. So we are not forcing you to a single full stack. You can choose the tools by yourself. So let's start with the APIs, and we start with the non-programmable APIs. You probably have seen those before. Starting with event handlers. So whenever something happens, you can run event handlers. For people used to Nagios using a Naemon, that's not a new thing. But it's still somehow an API where you can process things. There are a lot of tools based on event handler, so they are really run after each host and service check, and you can process the data into something else. This is possible as global host and service event handler, and also you can have specific host and service event handlers. Then we can process performance data in several ways. There are really many ways to do so, like the performance data command. You can write performance data into a file. You can then run this command to process those files, but there are more ways to do it. For example, with the Naemon Modules, what we talk about that later. And finally, another non-programmable API are this obsess over hosts and services, on these OSCP and OCHP commands. Also, they do what you would expect them to do, but of course, this has some kind of performance overhead, because for each host and service result, you will end up with at least one other fork and a script that's running, and Naemon has to wait until that thing finishes. So that's okay for simple things, but usually you want to get a little bit deeper into it. And that brings us to the next common APIs, like LifeStatus, the query handler, and or Naemon Modules in general. Like LifeStatus is a Naemon module as well. Starting with that, LifeStatus is a super cool API which provides data from Naemon, of course, but also allows you to send commands back to Naemon, and it supports multiple formats like JSON or native Python and CSV format. We'll have a look at LifeStatus in detail later. The query handler itself, it's used for the worker processes, which Naemon is using to run those checks. So the communication between the Naemon core and the worker is done over this query handler. But you can also do several other things with this query handler. So you can, for example, set internal variables. You can fetch statistics about the worker processes of Naemon itself. And you can also run commands through that query handler with the advantage that you will get an actual return value from the command. It's not a fire and forget. You get an answer. So you can see that if the command actually worked or if there are some errors through processing that thing. We added this functionality to LifeStatus as well, meanwhile. So if you send commands by LifeStatus, you will also get a result and see if that actually worked or not. And finally, we have those Naemon modules. These are more or less generic API, or actually loadable C libraries, which have direct access to the Naemon memory, so they can do whatever they want. But yeah, of course, with great power comes great responsibility. You can do a lot of things wrong, obviously, when fiddling in the memory of Naemon itself. Let's have a quick look at common Naemon modules. Like I said already, LifeStatus is, the yellow parts are actually things from the Naemon project itself. So we provide the Naemon core, and the Naemon modules are some kind of layer, and we provide the Naemon LifeStatus as a module, and that's what the Naemon project itself provides. And then, like I said, there are several things built on top of that. Like, for example, there are several LifeStatus consumers, like UIs, like Truck, NETWAYS, OP5, Monitor, and probably a lot of others I don't know about. And there are some other Naemon modules like Mod-Gearman, for example. This offloads checks onto different machines, so it's kind of load balancing. But you can also use it to expose metrics, for example, into NACFlux and InfluxDB and Grafana. Then there's Merlin, which is kind of you can build redundancy and high availability setups for Naemon with Merlin. And then there's Status Engine, which also exports data into a database and comes with an UI. We will have a look at those later. I've prepared some slides having detailed look at those things. And finally, of course, when doing checks, you always produce a lot of metrics, and we want to somehow process them further. And we have one example here, the MPCD daemon from the PNP project, which is also a Naemon module. So let's have a quick look at LifeStatus, which is for Naemon the most common way to access data, and it's, yeah, like I wrote there, it's fast, live, and it produces JSON, so that's usually everything you want. And next to this little example where you just fetch host names, it has also very powerful statistics, so you can run several statistics in one query. I'll show you that on the next slide. With Naemon, we put LifeStatus a little bit further. We added another output format like this wrapped JSON. I will show an example on the next slide. Next to a limit, we also had an offset, because it usually doesn't make sense to have a limit but no offset. So you can fetch a very specific area of the data. And we added sorting, because otherwise you would have to fetch everything. If you have to sort locally, then you have to fetch every data, sort it locally, throw away about 90% of that data, and just display that. So that's why we implemented the offset and sorting. Yeah, there you can see a small example of LifeStatus query. It simply fetches hosts, like only one single column, like the name, and we set the output format to JSON and limit that to just 2 hosts because, yeah, don't want to fill a screen with useless data. It's as simple as that, and there are many modules that somehow handle the query format for you. So there are Perl modules, Python modules, and etc. So you don't have to create that query by hand. Usually it's just to give you an idea how it looks. This one is the wrap JSON format. It puts the actual data in another hash array and gives you an additional total count. So this is quite useful, for example, if you have paging on your web page. So you fetch hosts, say, I'm only interested in the first 2 or in the first hundreds because that's how much I want to display on my website. But I also want to know how many it would have been, so I can print a paging bar so people can page through the data. Usually this would end up in 2 queries, like you have one query with the limit and doing that same query again with a counter so you can fetch how many items you would have gotten. And it's, yeah, the idea is to have a single query per page, so this one puts everything into one query and you get everything you need into one query. And the last thing I want to show with LifeStatus is the power of the statistics. It's still a very simple example, but here we fetch all hosts want to count things that have the state 0 or the state 1, and then you get a simple array with those numbers. And that's really quite powerful because, for example, if you imagine the technical overview page where you have maybe 20, 30 different numbers, like how many OKs do I have, how many warnings do I have, how many criticals do I have, how many criticals in downtimes do I have, how many criticals and acknowledge do I have, how many, I mean, you see, there are a lot of counters, and you can do it with a single query in LifeStatus, so that's really quite powerful. So, like I said, Naemon Core and Naemon LifeStatus is basically what's Naemon is about. So, which brings us to friends and have a look what is built on top of that. Starting with Merlin, that's a Naemon module from OP5. It's the module for effortless redundancy and load balancing in Naemon, and that's what it does. You load this Merlin Naemon module into Naemon, and Merlin then writes the configuration, the status data into a database. And if you want to have redundant setup, you just do the same thing again and connect the Merlin daemons so they can communicate and do the high availability for you. Next thing is status engine. This is another Naemon module which exports the Naemon data in JSON format, which is then put into a database. And it also comes with an web UI, so you can easily display the data. If you're interested in status engine, the guy, Daniel, is here. If you have questions about that, just ask him. He will happily answer your questions. It is mobile and big screen friendly, so it's really, yeah, it's shiny and nice, and you can have a look at your issues in a nice way. Another Naemon module is for Alerter. This is not really connected to Naemon, but it's a third-party tool processing alerts. But it comes with a Naemon module, so you can extract the notifications from Naemon and put them into the Alerter dashboard. And finally, another Naemon module. So if your favorite language is Go, then writing Naemon modules has never been easier. So we just put together a NAP wrapper for Golang. So you don't have to write your Naemon modules with C anymore. you can still do that, but you're also able to write your Naemon modules in Go now. And here's a very simple example. Basically, you import the library, set a few initial things like title, name, and so on. And Naemon modules usually work like you register callbacks, and then the Naemon core, whenever it hits such a callback, it will call your Naemon module, and you then can do whatever you want. I mean, always remember your callback is run synchronized with the core. So Naemon waits until your callback is finished. So if you're doing fancy web queries with large timeouts, that doesn't work. So really make sure you usually immediately return your callback, and then that's fine. So yeah, give that a try if you want to write Naemon modules in Go. Which brings us to FRAMETRAXX. The next Naemon modules, it's quite hard to put those things into boxes because like status engines is a Naemon module and a web UI, so it's maybe a little bit mixed up. PNP is still alive. It's, like I heard, there's a dark theme planned. So maybe we will see something new from that project in the future. So long, it actually does what it's used to. It writes performance data into RD tools and also comes along with a website to display that data again. And the reason why I mentioned it here is because it also comes with the MPCD module, which is a Naemon module for a very fast processing of the metrics. Another way of handling metrics is this combination of NACFlux, InfluxDB, His2, and Grafana. A lot more tools than one, but in the end you will get shiny Grafana dashboards straight out of Naemon metric. And it works like that. The NACFlux is the connection between the Naemon core and the InfluxDB. So NACFlux has several ways of communication. So it also can read the spool files where the metrics are just written into plain text files, but it's also able to consume metrics over Gearman queues, for example, so it can be offloaded on different machines like that, with that. Then it writes the metrics into the InfluxDB, but it also enriches the data with with the comments and the downtimes. So it's not only metrics, but it also adds metrics, downtimes, and comments. So in your Grafana dashboard, you can have the comments and downtimes as annotations, which is quite helpful. And you can put a lot of stuff in it. You can even put in screenshots into those annotations. So you can, for example, for end-to-end tests, you can see actual screenshots along with the graph for when the problem happened. That's quite powerful. And to create those dashboards, I mean, like Grafana is not somehow in any way connected to Naemon. So you need a way to put this host and service philosophy into Grafana, and you don't want to create thousands of dashboards just in order to view your data. And that's where His2 comes into play. His2 is a small PHP project with creates dynamically dashboards or dynamic dashboards for Grafana based on LifeStatus data. So on the backend, it connects to LifeStatus and sees what kind of performance data does this host and service have, and do I have some template which then creates the Grafana graph. It works a little bit, or the idea, we put a lot of ideas from PNP into that because there are a lot of good ideas in PNP actually. Like the template is defined by the available metrics. So if you check, no matter how it is named, returns round trip and packet loss, then use that template because then it's a ping usually. Or if it's not a ping, it still has round trip time and packet loss, and this dashboard would fit very well. But you can also have some other filters to apply dashboards to your host and service. You can also use the host and service name to really add some specific dashboard for the specific host and service. But usually it works best if you just stick to the metric names, because that's what defines your dashboard anyway. That's what the things you use later on. And here, just brought an example from Apache Check. It checks the Apache, and all those Apache processes are plotted here. So this again, it's already a more fancy dashboard compared to the default one. We saw some UIs before. Like I said, it's a little bit hard to put those things into boxes. So there's one project I'm usually busy with. That's the truck web UI. It comes with status pages reporting everything you want in your monitoring, like dashboards, business processes, and also a configuration editor for Naemon itself. So next to editing the text files, you can use a fancy web editor and create and change your hosts and services there. This is an example from the dashboard. It has OpenStreetMap support, and you can put your things onto those maps. Then some random tools which can be used with Naemon. Another project I'm involved with is LMD, not to mix it up with OMD. LMD is for LifeStatus only. It's a tool which consumes LifeStatus, and on the client side, it has LifeStatus API as well. So basically, it just consumes LifeStatus from multiple sources and provides a single LifeStatus socket or TCP to the front. So, I mean, the reason for this project was we started somehow with, we want to connect like 5 sites into truck, and some, no problem, 5 sites is okay, just connect it, that's easy. Then we were like 20 different locations connected to truck, and could be a little slow, but still somehow worked. But a couple of years later, we ended up with, right now, I think 250 different Naemon cores connected into a single truck instance, and that's not the end. So I think by the end of next year, we are at 300 different locations put into a single view. And I mean, you can imagine, usually you wouldn't create a website connecting to 300 databases and then separate these 300 databases across the globe. That doesn't make sense. It's obviously pretty slow. And LMD just comes in between and removes the latency more or less completely, because it works asynchronous and fetches the data for you and has everything in memory, so truck can, or basically every LifeStatus consumer can fetch data from LMD and display the results more or less immediately. Of course, maybe you have 3 or 5 seconds you're behind the real world, because LMD has to fetch the data all the time. But I think it's worth it, because otherwise you would have to wait maybe 30 seconds, 60 seconds till the page loads, and nobody wants that. And with LMD, page can load immediately because there is no latency to the remote sites at all. Then other people use it to, for example, to leverage core reloads. So imagine you have a huge Naemon instance with hundreds of thousands of services, and it maybe takes 30 seconds to reload. Usually the LifeStatus connection will go down. Your web page is empty because it doesn't have any data anymore. It couldn't connect to the database or to LifeStatus in this case, and will just show maybe an error or nothing at all. And after 30 seconds, when the core has reloaded, then everything is fine again, and you maybe don't want that. This is something LMD can remedy as well, because LMD notices that the core itself has reloaded, but will continue to serve the old data for a configurable amount of seconds. And after the core has reloaded, it will fetch and update all those data and just continue fetching things from LMD. And also, if you have multiple sites, they can be reloaded separately, of course. So if one site just reloads, you don't want to display an error just because the site is reloaded right now. Yeah, that's what LMD does. And as a little side project, it also comes with a REST API and exports Prometheus metrics. So gives you a little bit of bonus here. Another project I'm involved in is Mod-Gearman. It's, like I said already, it's a tool to offload running check plugins, but also notifications and event handlers, for example. I mean, there are usually two use cases here. There's the one use case, you just have too many host and service checks for a single machine, then you can just offload them to machines next to your monitoring host. And the other use case is you have a separated somehow network segment or a data center, and you don't want to cut thousands of holes in your firewall. Then you set up a Mod-Gearman worker there and run maybe a specific host group on that worker, and everything is processed with a single TCP connection through that worker. Actually not a new project, it also exists for several years now. But there's one thing new. This year we rewrote the worker in Go, actually, and this has a lot of advantages. So the previous Mod-Gearman worker was kind of a pre-fork model. So it started maybe 100, 150 workers, and then they waited to do the actual checks. And we don't have to do it with Go anymore. It's more or less event-based, so it's a single process. It forks all those checks and returns them to the Naemon core. It has two advantages. It uses way less memory, for example. I mean, even if a single worker only uses 5 megabytes of memory, if you have 100 of them, it already takes a specific amount, and this process more or less uses no memory at all. Another thing that came more or less with Go is you can easily compile this thing for different platforms, like for Windows, for example. So if somebody wants it, there is a Windows worker now. I don't know if, if that makes sense. Maybe not the worker, but there are other tools coming with Mod-Gearman, like the send-Gearman, for example. This is quite helpful, actually, on Windows. So you can send passive checks from your Windows machine over Gearman, and that's something that often came up. I mean, there was a send-Gearman exit previously, but it was really kind of a hassle to compile that thing, and now it's super easy. And like it's Go, we can easily export some metrics, like I show you in this example. So this worker just, it creates metrics for your checks, like how long did your check take to finish, or how much CPU did your check consume. And so you can create a nice dashboard and see, for example, your top plugins, like how many, in this case, check HTTP is the most common one in this example. But also, usually it's not a big problem to run hundreds of check plugins, so you are interested in the ones who consume the most memory and CPU. And if you scroll down, you will see the same graph, but sorted by CPU time, and so you can easily identify maybe check plugins which could be improved in terms of CPU usage. Yeah. That's so far for the tools. Let's have a look at complete suites for monitoring, starting with the OP5 monitor. It's based on Naemon as well, and it's probably brings everything you need for monitoring with it, like SNMP traps, and it has a configuration tool and log server. If you have questions about that, Jakob is here and is probably happy to answer questions about that thing. Next thing, based on Naemon, is Open IT Cockpit. The people are sitting here. And we'll answer questions about that. It's again, a tool based on Naemon, runs your checks, brings everything you want into in your monitoring, like event correlations. It comes with a report. Maybe each of those things are probably is worth a separate talk about. Yeah. And finally, OMD, which is a more or less a toolbox containing Naemon and many other useful things we use a lot. For example, like Grafana, Mod-Gearman, and all those stuff I showed earlier. Well, hard to create a screenshot of OMD because it's not really a specific tool. It's more or less an idea of monitoring and a Python script. And so this is how it looks in production. You just have several processes working together, and it's a single RPM and Debian package, so it makes installation easier, but it doesn't force you to use a specific tool set. So it's, like I said, it's a toolbox bringing all the stuff with it, and then you can choose the things you like. Finally, some words about where's Naemon heading, and there are at least two things which are more or less fixed already. We will port the status table to LifeStatus in Naemon. It comes up every now and then. People are asking for it, and yeah, that will come. We will add more dependency options to Naemon, like we already added dependencies into LifeStatus earlier this year. Dependencies were always kind of not really transparent because they were not exposed with LifeStatus, so you couldn't see it in the UI, and sometimes you were wondering why isn't that check running now, and it was because some dependencies for this check failed. We added that this year, and now you can see and fetch dependencies via LifeStatus as well. And another thing I want to end with is this thing we added to LifeStatus, or it's maybe more or less an idea of what to do. We integrated the query handler into Naemon LifeStatus. So okay. Simple example. Here I just echo the actual query into my live socket and get the result from the query handler. It's really just passed through. There's no magic involved here. We do that already for commands to get the result with LifeStatus. But it also offers so many possibilities because the query handler is like maybe the most underrated thing in Naemon. It's quite powerful, but nobody really uses it because, I mean, you get almost everything out of LifeStatus already, so you don't want to have two connections to maybe do the same thing. So the idea was to just pass through the query handler queries, but be able to access it with LifeStatus. And another idea, the basic idea was to can easily get your help, like VP stats. Let's see. Like some statistics out of the Naemon core, like how many workers are they running, how many jobs did they do, what PIDs do they have. That's one maybe use case. But you can also subscribe to events, and that's more or less the thing why we will do that. So you can subscribe via LifeStatus to your service and host checks results, and we are planning to use that to synchronize, for example, like LMD. So LMD doesn't have to fetch periodically every few seconds the host and service results from the Naemon core, but instead just subscribe on the host and service check results, and you have instant results done, and still only have a single connection to Naemon, and you don't have to create connections to 2 different sockets. Yeah. So. Yeah, that's what you just saw. We probably will change the format from this unformatted text to something useful, like JSON, for example. So the idea is really to just provide another API which can be consumed by third-party tools and process those things further. So this was just an example. There will be a way to export that as JSON format. So besides that, I think Naemon will just continue the way it is. We try to provide a stable thing which doesn't change every 2 weeks, but if we need that, we will provide valid APIs and fast APIs so people can build things on top of it. Yeah. That's about it. Thank you very much. Are there any questions?
Hi, you talk about dependency options. Is there a way to define parent groups? So I have a network parent, I have a SAN parent, I have a logical application parent, and so on?
That should be possible already. You can define multiple dependencies and parents.
Yes, okay.
Yeah. So actually I was talking about visualizing those existing dependencies. What are you talking about? This is already possible. You can have multiple parents and you can have multiple dependencies.
Yes, I could have multiple parents, but if I have 2 LAN parents, that's okay, but what if I have 2 LAN parents and 2 SAN parents, and 2 LAN parents are down, the machine is back, but the check says the machine is up because there are 2 SAN parents? My problem is I need grouping in parents.
Yeah, maybe that's something that should be more or less modeled with business processes, or I mean, a host doesn't have to be a physical host. A host can be anything. It can be an idea of this parent, for example. So
okay.
Maybe we would do it like that.
Okay, thanks.
Who is maintaining LifeStatus? I know it's also in CheckMK, and so is yours a fork of it, or the other way around, or are you synchronizing with each other?
Yeah, LifeStatus itself was invented by the CheckMK guys, and we forked it into Naemon because it's really quite powerful and useful. And so they are maintaining theirs, and we are maintaining ours.
Oh, okay. Is yours better in doing events?
Of course.
Not in general, but in doing some kind of event-based queries. There's a wait trigger statement in the LQL language, and I was hoping to be able to do some kind of pubs up pattern with it, but it's not really possible reliably. And I talked with them once, and they said, no, that's not high priority for us.
So I'm not really into their CheckMK LifeStatus, so I don't know what's possible there, but wait trigger are possible with Naemon LifeStatus as well. So, but if that didn't solve your problem anyway, it doesn't help you. Maybe then this subscribe mechanism is more useful for you.
Yes, that's interesting. Okay, thanks.
Anyone else? If not, then that probably concludes your talk. and you have another present to put on your shelf. Thank you very much.
Thank you very much. Thanks.